In the heart of North America, Yellowstone's forests, lakes, and grasslands paint a picture of peace. Herds of bison roam, rivers carve ancient canyons, and geysers punctuate the landscape. But beneath this beauty, a force of unimaginable power lies in wait. The ground is alive, heated by a colossal magma chamber just below the surface. Geysers like Old Faithful are not just attractions, they're pressure valves for the restless earth. The air carries a faint sulfur scent, and the ground trembles with thousands of tiny earthquakes each year. Yellowstone is a supervolcano, a sleeping giant capable of eruptions that could alter life on Earth. The serene forests and meadows sit inside the crater of this behemoth. We are, quite literally, standing on the lid of one of the planet's most powerful forces. To understand Yellowstone's power, we must look back in time. The Yellowstone hotspot has left a trail of gigantic calderas across the continent. 3 super eruptions shaped this land: Huckleberry Ridge, Mesa Falls, and Lava Creek. The first, over 2 million years ago, ejected thousands of times more material than Mount St. Helens. Each eruption blanketed North America in ash, altered climates, and reshaped the land. The most recent, 631,000 years ago, created the Yellowstone Caldera, so vast it's visible from space. These eruptions remind us that Yellowstone's reach is continental, even global. Yellowstone's volcano isn't a single peak. It's the landscape itself. The caldera is a vast, forested basin, formed when the ground collapsed after the last super eruption. Gentle slopes called resurgent domes mark where magma pushes the caldera floor upward, even today. The ground swells and contracts, monitored by geologists with precision. Over 10,000 hydrothermal features, geysers, hot springs, fumaroles, are powered by the heat below. Water seeps down, heats up, and erupts back to the surface, revealing the volcano's inner workings. The hydrothermal system is dynamic. Geysers can go dormant or awaken overnight. Yellowstone's caldera is not a relic. It's an active, ever-changing volcanic landscape. The land itself is a living, breathing entity. Yellowstone isn't dormant. It's breathing. Beneath the surface, a vast, complex magma chamber pulses with heat. This heat drives the park's vibrant hydrothermal systems, like the colorful Grand Prismatic Spring. Geysers and hot springs act as natural release valves, preventing dangerous pressure buildup. Sometimes, pressure escapes violently in hydrothermal explosions, hurling boulders and creating craters. Every bubbling mud pot and steaming vent is a sign of the volcano's vitality. Yellowstone is one of the most dynamic places on Earth. Its constant activity is a reminder that the supervolcano is very much alive. The question isn't if it's active, but how we interpret its many moods. Yellowstone experiences up to 3,000 earthquakes a year, most too small to feel. These tremors are the background noise of a restless system, caused by shifting magma and tectonic plates. Sometimes, earthquakes occur in swarms, signaling changes deep underground. The 1959 Hebgen Lake earthquake, just outside the park, triggered landslides and altered geyser activity. Seismic activity provides a window into the volcano's inner workings. Scientists use these tremors to map the magma chamber and monitor for warning signs. A sudden change in earthquake patterns could signal an impending eruption. Yellowstone's ground rises and falls, as if the Earth itself is breathing. This ground deformation is caused by changes in the magma chamber below. Scientists use GPS and satellite radar to measure these subtle movements with incredible precision. The caldera floor has experienced periods of rapid uplift and subsidence, sometimes rising inches per year. These changes are normal, but sudden, dramatic shifts could indicate trouble. Monitoring ground deformation is like taking the volcano's blood pressure. Long-term trends are important, but rapid changes are the real warning signs. The land's slow, rhythmic breathing is a key to understanding Yellowstone's state. Monitoring Yellowstone is a monumental task, handled by the Yellowstone Volcano Observatory, YVO. YVO is a partnership of agencies and universities, using a network of instruments to track every tremor and change. Seismographs, GPS stations, and gas sensors feed real-time data to scientists. The University of Utah's team monitors seismic activity, ready to flag any unusual patterns. Collaboration is key. Experts in geology, seismology, and chemistry work together to interpret the data. Their vigilance ensures that any sign of unrest is quickly detected. YVO stands as the watchful guardian of this powerful natural force. Predicting eruptions is challenging, but volcanoes rarely erupt without warning. Scientists look for three main signals: intense earthquake swarms, rapid ground uplift, and changes in gas emissions. Harmonic tremor, a continuous low-frequency vibration, often precedes eruptions. Dramatic ground deformation, measured in feet over weeks, would be a red flag. A spike in sulfur dioxide gas signals magma nearing the surface. It's the combination of these signals, not just one, that indicates an eruption is likely. Modern monitoring gives us the best chance to anticipate Yellowstone's next move. Yellowstone's eruptions come in many forms, most of them far less catastrophic than people imagine. The most common events are hydrothermal explosions, violent but localized. Lava flows, while destructive within the park, move slowly and allow for evacuation. The rarest and most devastating scenario is a super eruption. Such an event would begin with intense earthquakes and rapid uplift, followed by a cataclysmic ash and gas eruption. Pyroclastic flows would devastate the immediate area, while ashfall could blanket much of North America. Global impacts would include a volcanic winter, crop failures, and climate disruption. While possible, a super eruption is extremely unlikely in our lifetimes. Most hazards are local and manageable, not apocalyptic. Popular culture often exaggerates Yellowstone's threat, depicting sudden, world-ending eruptions. In reality, a super eruption would be preceded by clear warning signs, weeks or months of seismic and ground changes. The most severe effects would be local. Ashfall, not blast waves, poses the greatest widespread risk. The annual probability of a super eruption is about 1 in 730,000, comparable to a major asteroid impact. Volcanic systems don't follow schedules. Past intervals are averages, not predictions. Sensationalism can create unnecessary fear, overshadowing real, manageable hazards. The true story is one of scientific vigilance and discovery, not impending doom. Yellowstone is a place of wonder, not just a source of anxiety. Yellowstone is a place of breathtaking beauty and immense power. It reminds us that the ground beneath our feet is alive, shaping and reshaping our world. Visiting Yellowstone is to stand at the intersection of awe and humility. The park is a living laboratory, revealing the deep processes that govern our planet. Understanding Yellowstone inspires respect, not fear. Science and vigilance are our best tools for living with such natural wonders. Yellowstone is both a warning and an invitation to learn, to respect, and to marvel at the forces that shape our world. By studying and preserving this landscape, we gain insight into the very nature of our planet.